Hi everyone, I am Satish here. Welcome to the problem solving sessions on physics. Let's look at the first problem on electric potential and capacitance. If 100 joules of work has to be done in moving an electric charge of 4 coulomb from a place where potential is minus 10 volt to another place where potential is V volt, find the value of V. Okay, let's look at the diagram now. Here we have point A and here we have point B. Okay, at A we have 4 coulomb of charge and 100 joules of work has to be done in moving the charge of 4 coulomb from A to B. Okay, so they have given that at point B there is V volt, so we need to find out the value of V here. As we know, the work done must be is equal to potential difference into charge. That's what we discussed. So they have given work done as 100 joules. That must be equal to potential difference. That is what? V at point B minus V at point A into charge mode. Charge mode is 4 coulomb. So that is equal to, at point B we have V volt, at point A we have minus 10 volt. So we need to calculate the value of V. So therefore we can say that 100 is equal to 4V plus 40. Is that correct? So therefore 4V is equal to 100 minus 40 is 60 and V is equal to 15 volt. So the potential at point B is 15 volt. So let's look at the next problem. Calculate the potential at a point P due to a charge of 4 into 10 to the power of minus 7 coulomb located 9 centimeter away. Hence obtain the work done in bringing a charge of 2 into 10 to the power of minus 9 coulomb from infinity to that point P. Okay, so we need to find out the potential at point P, that is 9 centimeter away. Let me say V is equal to 1 by 4 pi epsilon naught into Q divided by R. This is what the formula we need to use to calculate the potential at any point. So that is equal to 9 into 10 to the power of 9. That is what the value of 1 by 4 pi epsilon naught. The charge is 4 into 10 to the power of 4 into 10 to the power of minus 7 coulomb divided by the value of R is 9 centimeter away. So this is 9 into 10 to the power of minus 2 centimeter. 9 into 10 to the power of minus 2 meter. So suppose if I simplify this, I will get 4 into 10 to the power of how much? It is 4 volt. Exactly. So this is what the potential at that point P. Say let me as the point P. Okay. So Vp is equal to 4 into 10 to the power of 4 into 10 to the power of 4 volts. So we need to calculate, hence obtain the work done in bringing a charge of 2 into 10 to the power of minus 9 coulomb from infinity to that point. As we know, the work done is potential difference multiplication with the charge mode. So potential difference is V at point P minus V at infinity into charge. So therefore we can say that V at point P is, just now we have calculated, it is 4 into 10 to the power of 4 volt minus potential at infinity is always taken to be 0, multiplication with charge. Charge is, how much is that? 2 into 10 to the power of 9 coulomb, minus 9 coulomb. Okay, so suppose if I simplify this, I will get 8 into 10 to the power of minus 13 joules. This much amount of work has to be done to bring a charge of 2 into 10 to the power of minus 9 coulomb from infinity to that particular point P. Let's look at the next problem says two charges 3 into 10 to the power of minus 8 coulomb and minus 2 into 10 to the power of minus 8 coulomb are located 15 centimeter apart. At what point on the line joining the two charges is the electric potential 0? Take the potential at n infinity is 0. Okay, very important type problem. See, we have two charges, that is 3 into 10 to the power of minus 8, 3 into 10 to the power of minus 8 coulomb, and which is separated by distance of 15 centimeter from the one more charge, that is what, minus 2 into 10 to the power of minus 8 coulomb. Okay, so we need to find out the point, that is a line joining the two charges at which the potential must be equal to 0. Say at point P the potential is 0, which is at a distance of x from the charge 3 into 10 to the power of minus 8 coulomb. So what's the distance? Say this is point A and this is point P. What is the distance PB? It must be 15 minus x centimeter, correct? So this is what the distance between P and B. So let's try to apply the principle of superposition for the potential at point P. So we can say that potential at P is equal to 1 by 4 pi epsilon naught into Q divided by x plus 1 by 4 pi epsilon naught charge at point B divided by 15 minus x. So this is A, say this is A, QA. Okay, suppose if I take 1 by 4 pi epsilon naught common, this is 1 by 4 pi epsilon naught common, what I left with, this is 3 into 10 to the power of minus 8 coulomb divided by x plus minus of 2 into 10 to the power of minus 8 coulomb divided by 15 minus x. So they have given that potential at point P must be equal to 0. So let me make it as 0. So therefore 3 into 10 to the power of minus 8 divided by x is equal to 2 into 10 to the power of minus 8 divided by 15 minus 6. Suppose if I simplify this, I will get 3 by x is equal to 2 divided by 15 minus x. So therefore 15 45, the sense 5x is equal to 45, or x is equal to 9 centimeter. That is the answer for this particular question. So at 9 centimeter from 3 into 10 to the power of minus 8 coulomb charge, the resultant electric potential is 0. So thank you for watching this video. Good luck.